Okay, so now I will put the magnet to these tanks and what will happen?
吸住咗。哇！
好啦，咁咧佢吸住上面嗰啲好正常，點解下面嗰啲都會俾人吸住？
因為佢下面都 polarize 咗，然之後。
唔係 polarize。
下面。
咁咧，但下面嗰啲咧冇 not directly connected to the magnet, but it is still to be attracted. Why? 咩啊？
佢可能唔太。
點解唔係咁？點解佢唔會凌空吸喺度唔喐？佢一定要掂住，起碼佢掂住某一嚿金屬啊嘛，係咪？即係因為話唔一定要掂住先吸到，咁但係你唔會見到呢嚿嘢凌空定咗喺度。
掂住嘅話，佢上面個鋪就。
哇！即係再行應該唔掂。好，咁我擺翻低佢先。好啦，點解？Now, so I use the magnet. Okay, so I use this magnet to attract a clip. Okay, so and another clip can be attracted below it. Why? So it seems that the above clip becomes a magnet. Okay, so in this case becomes a temporary magnet. Or we can say it's not polarized, okay? So we can say this clip is magnetized. Okay, so we magnetize the clip. Okay, so and then the clip becomes a temporary magnet. So now we can treat this clip be a magnet. So which end do you think is a north pole? So which end is the south pole? 邊邊係 north 邊邊係 south 啊？你覺得？如果呢嚿嘢變咗 temporary magnet，
上面係 south，
係啦，上面係 south， 下邊係 north， 咁樣佢先會黐埋到啊嘛，係咪？咁所以上面咧就變咗 south。Okay, so the below part becomes the north pole. So same to the lower one. So the lower ones will be magnetized by the magnet and this clip. Okay, so and the upper part will become south pole, and the lower part will become north pole. Okay, so we call this magnetized. So originally these clips have no magnetic properties, but when we put the magnet here, it seems that it becomes a magnet. So in this case, we call this magnetized. But what is the reasons behind the magnetized? So why will the metal be magnetized?
嗰啲。
點解佢有啲會 magnetize， 有啲唔會俾人 magnetize 嘅
？Metallic bond。
點解？
嗰啲 electron。
咁咧就同後面個版有關係。有啲係 turn your book to page 192. So in the enrichment box, so there are two diagrams to talk about the magnetized and not magnetized materials. So for this clip, so if we enlarge the clips, okay, so if we enlarge the clips, then we'll find that there are a lot of small magnets inside the material. Okay, so like we mentioned the last two periods. Okay, so this directions, these arrows shows the orientations of the magnets. 或者咧，如果你唔想見到箭嘴咧，你可以撳下藍嘅箭嘴上面嗰度係 north， 呢度係 south。So each 係啊。So now they are randomly aligned. Okay, so or we can use an arrow to represent the orientations of these small magnets. Okay, so we call these small magnets as the domains. Okay, so they are called magnetic domains. Okay, so in this case, this material showed no magnetic properties. Okay, so because those small magnets are oriented randomly. Okay, so when you put a magnet next to it, for example, when we put a large magnet next to it, then what will happen to this domain? So what will happen to this domain in this case?
It will go to the same direction.
Okay, so the magnetic fields generated by the magnet will pass through those domains. Okay, so and then to make the domains align perfectly along the magnetic field lines. Okay. 或者你可以諗咧，呢度咧變咗收，呢度變咗 lock。So those small magnets will now be affected by the external magnetic field. So they align perfectly. So if you take a top field, then all small magnets are now aligned perfectly, right? So we can treat this as a large magnet. So when there is no magnetic field, those small magnets are in random direction. So they show no magnetic properties. So they cancel each other. So when you put a magnet next to it, those domains will align perfectly. So we can treat this as a magnet. So this is the principles of magnetize. Okay. So why you can magnetize the materials is just because you put the external magnetic field here to force those small magnets inside the materials to align perfectly. So you can imagine that this is the clip, okay? So you can imagine that this is the clip attached here. So if we attach the clips here, then this part becomes south pole, this part becomes north pole, because they are magnetized. So when we put another clip here, so the same things will happen again. So the another clip is now magnetized by the previous one. So this becomes south pole, and this one becomes the north pole. Okay. So that's why those clips can be attracted as a series. Okay. So you can attract a lot of clips with the same magnet. Okay. So in this case, we call this the magnetized. But do you think all materials can be magnetized? So of course not. For example, 你哋學校個窗框咧應該就唔可以 magnetize，係咪？咁咧佢係 no magnetic force 嚟，點解啊？呢啲窗框係攞咩整嘅？
膠。咩？
係攞咩整啊？呢個？
不鏽鋼。
唔係不鏽鋼係 magnetic materials 嚟嘅。係啊，你成日聽啲人講咩鋁窗脫落啊嘛，所以係 aluminium 嚟嘅。So aluminium is not magnetic materials, and it is very difficult to be magnetized. Huh? 如果佢係 pure 嘅 aluminium 就唔得 ，copper 都係唔得嘅。所以咧，你識嘅嘢咧，基本上就係 iron 就呢嚿嘢啦。譬如呢堆應該就係不鏽鋼，咁你就可以黐喺度咯。咁呢個 fault 都應該可以不過咧因為唔夠強啊，要買佢哋公司嘅產品呢4粒嘢咧先可以吸到上嚟。OK， 好，咁咧，所以咧由呢個 magnetize 咧，我哋可以分做幾種 materials 嘅，咁咧一種就係 non-magnetic materials， 你都要直頭 magnetize 唔到咁嗰啲咧就唔使諗啦，係咪 ？So for example the copper and aluminum. So by the properties of magnetize, okay, so we can divide it into magnetic soft and magnetic hard materials. 咁咧呢個你本書冇嘅，一定要抄啊 ！IGCSE 會出嘅。Okay, so magnetic soft material. in the magnetic hard material. Okay, so what is magnetic soft materials? So the material is magnetized or demagnetized. Easily. Is used is magnetic property, just alter the external. 有咁字文就咪抄。The external magnetic field is removed. Okay, so for example, soft iron. 有咩你叫啊？好 soft。Okay. So if the materials is called magnetic soft materials, and when you put the magnet next to it, it will be magnetized immediately. However, when you remove the magnet, it will be demagnetized at the same time. Okay, so those magnetic properties will be remained. So for the magnetic hard materials, okay, so it's different. Of course, it's opposite to the magnetic soft materials. So okay, so the examples of magnetic hard materials is steel. Okay, so steel is one of the magnetic hard materials. So for the magnetic hard material, so it may not be difficult to magnetize, okay? So you may be magnetize it easily. However, it's very difficult for you to demagnetize the materials, okay? So that means after you remove the magnet, so if the clip is made up of magnetic hard material, so if the clip is made up of magnetic hard material, even if you remove the magnet, so the clip still behave like a magnet. Okay, so it can still attract the other clips. Okay, so that's called the magnetic hard materials. Okay, so if you magnetize the magnetic hard materials, then maybe it will demagnetize after 1 week or even month. Okay. So do you think this clip is made up of magnetic hard or magnetic soft materials? Soft 定 hard 啊？咁咧，如果我掹咗呢粒 magnet 啫，你覺得下面會唔會跌晒啊？即刻？ 咩啊？唔係，其實係我捉住咗佢嘅。我淨係捉住上面，其實都有少少見唔見到？即
都幾疏。
我太近啦，夠 magnet。咁咧，佢肯定會需要一段時間先會 demagnetize 到嘅，但係佢都係算 magnetic soft materials 因為當你 remove 咧，其實佢都係會跌落嚟嘅。咁所以咧就可以分成呢兩種。咁當然仲有一種就係 non-magnetic materials。So for example, the aluminium 就係 copper。Okay? So it will
嗰個 P field 係咩
B field magnetic field。係喎，你哋未學呢個 B 喎？呢個 B 係 magnetic 嘅意思。嗰嚿 magnet 咧，有啲嘢天生就有 magnetic properties 嘅，係咩啊？上次講咗。嗰啲咩 Fe 啊、Mn 啊、V 啊 ，so periodic tables. Okay, so the transition metals are magnets. Okay, so or Ni. 咁咧有啲咧你可以自己整到佢變 magnet 啫。For example, if you make a steel and then you rub it with the magnet every day, then it may becomes the magnet. Okay, so and able to stage for a very long times. Okay, so I'm going to move to the next page. So, it tells you how to find the magnetic field lines around the magnet. So if I give you this magnet, okay, so normally we use red to represent the north pole and blue to represent the south poles. Okay, so don't have to be white. So if I ask you to draw the magnetic field lines, so what can you do? It's a bit different from the charges, right? So because they are not separated. So in this case, the two magnets are attached to the same bar. So we call this the bar magnet. So how to draw the magnetic field lines? How to draw the magnetic field lines around this bar magnet? So if I give you a compass, then what can you do? 我俾個指南針你，你可以點畫啊？我俾個指南針你，你可以點畫啊？
嗰個收。
如果你想象一下，我擺個指南針喺度咧，哎呀，咁指南針嗰條藍針會指向邊度啊？北。係啊，咁嗰條藍嘅會指向呢度啦，係咪？個箭嘴係咁嘅，箭嘴係北嚟嘅。唔係指南針個箭嘴北，咪有啲問題呢個嘢。指南針咧有個紅色嘅地方咧係篤住北邊嘅，我試試先。唔係喎，佢紅色嘅地方係篤住南邊。哇！真係指南針嚟喎呢個。唔緊要啦，嗱呢度有支針啊嘛，呢度有支針 ，OK。咁啲針咧就會轉到去咁嘅樣啦。咁咧呢邊就係支針嘅，呢個支針嘅收鋪啊。OK， 呢個係支針嘅 north pole。OK， 好啦，跟住咧，你咧擺個 magnet 喺度係咪可以畫低支針嘅樣啊？跟住咧就再喐一喐個 magnet， 跟住咧就可以畫低支針另一個樣啦。OK， 跟住咧你就不停咁攞個指南針咧擺喺度，不停咁畫，不停咁畫，不停咁畫，不停咁畫，跟住最後你再連埋晒啲針咧，咁你就可以畫到呢個 magnetic fields。OK。呢個咧係一個窮人嘅畫法。如果你好有錢，可以點做啊？係啊，你可以擺100個指南針喺度咯，跟住就連埋晒啲針，咁就得啦。即係佢同 electric fields 唔係好一樣，啲 electric fields 咧好難可以睇到，但係 magnetic fields 唔同啊。咁仲有一個方法嘅就係你擺個 magnet 喺度，擺張 A4 紙喺度，跟住可以點做啊？你可以滲啲鐵粉落去，跟住 shake 下佢，跟住咧佢就會 align like the magnetic field lines patterns. Okay? So now I will tell you what are the patterns of field lines around it. 咁咧佢同 electric field 有少少唔一樣嘅，咁咧你本書都冇嘅，所以咧你都係要畫啦呢個。So there is no magnetic field lines around a single bar magnet in your books. Okay, so the field lines will start from north or south. Will it start from the north pole or south pole?
South.
嚇？ No, wrong.
North.
The magnetic field line starts from the North Poles. Okay? So the field line starts from the North Poles. 冇點解，因為嗰個人 define。好啦，咁咧其他咧差唔多樣，係咪？咁咧，哎呀，其實咧呢個圈咧係連埋一齊嘅。喂輸油咩？邊度有啊
193。
係喎，193仍然係有喎。咁算啦，有就得。Okay. So and how can we measure the magnitude of the magnetic field? So the unit is T. Okay, so which is Tesla. 呢排好出名嘅，成街都係嗰部車，係咪？咁咧 ，the unit for the magnetic field is Tesla. And there are some different patterns of the magnetic fields. You can turn your book to page 195, 195, 195. Okay. So if you have two bar magnets, then you can treat them as positive charge and negative charge, and then you draw the magnetic fields patterns. So North Pole is like the positive charge. South Pole is like the negatively charged. Okay. So you just apply the method, you draw the electric fields, and you will get the patterns. So similar to two terminal plates, similar to two parallel plates. Okay, so if you have two parallel magnets, okay, then the magnetic field lines will be parallel in between. Okay, and then now turn to page 197. Page 197. So there are three devices for measuring the magnetic field. Okay, so you can take put a cross here first. Okay, so it's not included in the test. 呢三個咧唔需要住嘅，我哋講後面嗰課就順便講埋。197. Okay, so 197 is not included inside the test. And now I will pass you these things for you to see the magnetic fields. So you can put the magnet here. So and there are lots of small needles so on the plate. OK， 咁咧你擺喺黑色嘢上面睇唔到嘅，咁所以咧就擺喺張白色紙上面咁一個。咁咧我有兩種 shape 嘅，一種咧就係呢個馬鞍形狀嘅 magnet， 一種就係呢個 bar magnet。再附送埋一個指南針，咁咧大家可以擺喺度睇一睇咧佢嘅 magnetic field， 其實咧好明顯嘅，即係咁樣嘅 magnetic field lines。So now this is better than the electric field, so you can see the field lines around those magnets. Okay. So for the patterns and the directions of the magnetic field, so it's similar to the electric field lines. Okay, so if I ask you to draw me the directions of the magnetic field lines at this point, at this green point, so what is the directions of the field lines? 記唔記得個 direction 係點樣畫㗎？係啊，就係嗰條 tangent 咯 ，OK？The direction 係呢度。So it's all similar to the electric field. It's similar to the electric field. So we have finished this section. So now turn to page 200. So turn to page 200. Okay, so beside the magnet, how can she create the magnetic field? 如果我叫你咧 create 一啲 magnetic field， 但係唔俾用 magnet 咧，咁你可以點做啊？可以點做？ 仲有啲乜嘢可以 create magnetic field 㗎？仲有啲咩可以 create magnetic field 㗎 ？Okay, so as you can see, this book is called Electricity and Magnetism, right? So actually, these two things normally appears and almost always appears at the same time. So actually, when you have wire with current, it can generate the magnetic fields around it. Okay, so for example, if you have a single wire here, if you have a single wire here, so if the directions of current is pointing up, then there is a magnetic field around this wire. Okay, so how to find the directions of magnetic fields? 你覺得呢個 magnetic field 係點咧？譬如咧，而家呢度有支筆啦，佢個頭咧就係嗰個 current 嘅 directions。而家 current 向上，咁佢個 magnetic field 係點啊？你覺得？佢個 magnetic field 係向住呢邊啦，射開啊，圍住佢轉啦，向上下啊，定係點樣咧？Okay, so you can use your right hand to find the directions. Okay, so we call this the right hand grip rule. 淨係可以用右手嘅啫，呢個咁你用右手咧，想像一下，你捉住呢條 wires， 而家咧呢條 wires 嘅 current 向上啊嘛，係咪？你右手捉住呢條 wires， 跟住呢4隻手指喺度轉，咁呢4隻手指向住邊個 directions 轉啊？真係要咁樣揾嘅，你以後都要咁樣揾啊，所以你一定要學，你唔好喺度瞌眼瞓。呢個係你用左手咪倒轉咗 directions 咯？你用左手係咪就係咁樣轉啊？如果你咁樣捉住佢，你用右手咧，呢4隻手指咧會咁樣轉嘅，係咪 ？So both things。快啲拿出嚟啊！你出嚟。嗱，大家睇住佢啦。呢個係 current， 攞隻右手出嚟捉住佢。咁你而家捉住個拳頭啊？唔係。咁樣係咪？你見唔見到嗰4隻手指嘅方向啊？呢4隻手指咧向住呢邊轉過去嘅。呢4隻手指，你捉住佢嘅時候，呢4隻手指係咪向住呢個方向轉過去啊？所以個 directions of magnetic fields 就係咁樣啊。如果講咩啊？如果 directions of current 向下，咁咪手指公就向下啦。而家手指公係 directions of current， 所以咧就係咁樣啦。如果而家係咁樣咧，你就要咁樣捉。咁向左咪向左咯，手指公咪向左咯。喂，咩你講咩 ？magnetic fields， 即係你有個 current， 呢條係 wires with current 嘅，咁你有 current 咧就會 create magnetic fields 啦。綠色嗰個咧係 directions of magnetic fields 嘅，綠色嗰個箭嘴咧係呢個 magnetic field。OK， 綠色嗰個咧係 magnetic field。好。咁你想像一下，如果咧而家條 wires 咧黐喺度，大家都望住啦，啲 GIF 嚟嘅過咗就冇啦。條 wire 咧擺喺呢度，咁我呢4隻手而家轉啊嘛，咪捉住佢轉啊。呢4隻手指捉住佢轉啊嘛，係咪？咁呢4隻手指咧？喺呢條 wire 右邊咧向入定向出啊？向入，因為我咁樣捉落去啊嘛，係咪？咁喺呢支筆嘅左邊係向入定向出啊？向出係咪？因為佢咁樣轉入嘅，咁所以咧個 magnetic field 咧 ，the magnetic field is pointing inward. We use cross to represent the inward magnetic fields. The magnetic fields pointing inward on the right hand side pointing outward. On the left hand side. Okay? So 呢張紙用唔用得㗎？2020年度中5級公民教育課堂。冇人㗎。好啦，咁咧嗱點樣去理解咧？如果呢個就係 directions of current 啊，呢個 directions of current 我而家咪要捉住佢啊喺呢個 plane 度。咁我呢4隻手指係咪要插入去啊？咁呢4隻手指咧就會插穿咗，即係向住呢度入邊。呢4隻手指向入，咁呢個 cross 就係代表 pointing inward 啦。呢個 cross 係代表 pointing inward。咁咧，我隻手指會喺呢度出翻嚟嘅，係咪？因為我而家咁樣捉住條 wire 㗎嘛，喺呢邊出翻嚟嘅，所以呢個 dot sign representing the magnetic field pointing outward。好啦，而家咧要俾少少想像力啊，有冇想像啊？
冇。
呢條 wire 咧而家係喺上面㗎嘛，好啦，你而家喺上面望落去會見到啲乜嘢？即係條 wire 係咁㗎嘛。係。你當而家上個 visual art 你喺上面望落去會見到啲咩啊？有個圓圈。係啦，有個圓圈。咁呢個圓圈嘅 current 係出緊嚟定行緊入嚟啊？呢個圓圈嘅 current 係出緊嚟定行緊入嚟啊？你咁樣望。出緊嚟啊嘛，係咪？出緊嚟咧就係 dot 啦。咁咧呢一個符號咧就代表一個 wire with a current moving out。OK？ 呢個符號咧代表 wire with the current moving in。有乜分別啊？呢個同呢個？呢個同呢個有乜分別啊？呢個多咗個圈，見唔見到啊？即 cross 咧就代表向入咯。如果有個圈咧就代表有 wire 喺度，所以嗰個 cross 咧而家就係 current。OK？ 如果你淨係一個 cross 咧就係 magnetic field lines 嚟嘅。
即左邊呢個係 magnetic field，右邊呢個。
唔係，即唔係，佢先答佢個問題先。佢唔明，即如果你見到呢個 cross，就代表而家有條 magnetic field line 向住呢度。如果你見到呢個圓圈加 cross， 而家就有一條 wire 個 current 向住呢度。條 wire 啫，而家係咁樣。條 wire 而家係 3D 嘅啦。條 wire 而家係咁樣。跟住而家條 wire 係咁樣嘅，跟住 current 向住入邊。current 向住入邊。呢條 wire 都係咁樣 current 向住出邊。OK 嘛？如果你見到呢度一個圈加點就係咁咯。淨係見到個 cross 咧就係個 magnetic field 向住入邊。而家呢條 wire 係咪咁樣啊？條 wire 向上㗎嘛，所以你喺上面睇落去，嗰條 wire 同埋就係咁樣行咗出嚟咯。呢個 O 唔 OK 啊？嗱，你而家條 wire 係咁樣，我喺上面望落去，咁咪就係見到咁嘅嘢啊。咁呢個圓圈加點咧就代表個 current 向嘅出啦。到你問啊？冇嘢啦。冇嘢啦。你問啦。唔係，呢個紫色嘅咧係 field lines， 我未畫右邊個 field lines。咁右邊個 field lines 會向邊度啊？即係點畫啊？右邊個 field lines。如果喺上面望落去嘅 field lines 係咩樣啊？下面。係咯，攞隻右手出嚟咯。係。而家左右同我有優勢啦，不過好快就失去呢個優勢啦。你而家手指公咧 directions of current 啫嘛，係咪？所以而家手指公向住出邊，你4隻手指係咪咁樣轉啊？係。咁樣而家就容易睇好多啦，4隻手指係咁樣轉，所以咧就係咁樣啦。個 directions of magnetic field lines。OK， 你中意點樣都得嘅，係啊 ，Dorothy 好黐線，你咁樣同咁樣係冇中意嘅。你中意咁樣咩？你擺到就得㗎啦。好啦，我畫翻圓少少先，因為咧，呢個 field line 有咩特別啊？佢有好多層。佢唔係呢個 field line 唔係好對稱嘛？我定你。算啦，就講啦。數學老師畫先圓㗎嘛。
數學老師直接用內建嘅。
高級啊，數學老師。你見唔見到呢個 spacing 咧越嚟越遠啊？點解啊？其實 for the electric fields when the spacing is increasing, what's the meaning？ Yes, the magnitude is decreasing, right? It becomes weaker and weaker. The same for the magnetic field. So if it's a part further away from the wire, then the magnetic field strength will become weaker and weaker and weaker. Weaker and weaker and weaker. Okay? So this is how to find the directions of the magnetic field. Okay, so we call this the right-hand grip rule. 有名嘅呢個咁中意病嘅手法係叫做 right hand grip rule。OK， 中文有個型啲嘅名嘅，叫右手螺旋定則。
哇！
好，咁咧而家咧就俾大家示範一下先。So if you have a wire pointing to the right hand side, what's the directions of magnetic field? Okay? So if you have a wire pointing to a tilted angle, so what's the directions of the magnetic field? Okay? So if you have a 呢兩個畫埋啦，雖然啱啱畫過好簡單。So if you have a wire coming out, what's the magnetic field around it? If you have a wire pointing in, what's the magnetic field around it? So give you 2 minutes to draw the magnetic fields. Okay, so give you a 3 minutes break.
咁我應該係咁如果你話畫magnetic field係應該畫嗰啲箭嘴定係畫交叉零點？交叉零點。
通常呢啲係畫交叉零點，呢啲係畫箭嘴。陣間就會講啦，你 break 邊啊？唔識就繼續。3 minutes break。break 翻啦而家。喂，陳頭哥，你點係 point hour 嘅？佢似乜嘢啊？所以佢 point hour。
哇！突然間好頭暈。